We'll talk in this lesson about containers. Now, containers are a technology that allows you to encapsulate an application and its dependencies into a container. This approach ensures that the application will run uniformly regardless of where the container is deployed. So in essence, a container is a lightweight, standalone and executable software package that encompasses everything needed to run a piece of software, including the runtime, the system tools, libraries and settings. Now, the idea of containers isn't new. Unix has had features like chroot since the 1980s, which allowed processes to run in an isolated file system, and the modern container ecosystem as we know it gained traction with the rise of Docker in 2013. Now, Docker simplified container management and image creation, making it accessible to developers and operators. Now, unlike virtual machines, which include a full operating system and simulate physical hardware, containers run on a single system OS or operating system kernel and isolate the application processes from each other. Containers share the same operating system kernel but maintain their file system, libraries, and application processes. Now, containers are composed mainly of a container runtime, and this is the software responsible for running containers, and examples include Docker, Containerd, and runC. And we also have the image, which is a lightweight standalone executable package that includes everything required to run a piece of software, including the application and its dependencies, the runtime, system tools, and system libraries. And it's immutable, meaning it does not change. And we also have the orchestration. The orchestration manages the life cycle of containers, especially in large dynamic environments, and Kubernetes is the most popular container orchestration tool. Now let's focus on Docker, for instance, and the Docker client is the primary means users interface with Docker, so they issue commands to the Docker daemon through this. Now, Docker build, pull, and run are the commands that clients can run, and Docker build initiates the creation of a new Docker image from a Docker file, and Docker pull fetches an image from a Docker registry to the local system, meaning that your local computer or local machine. Now, Docker run launches a container from a Docker image, and then we've got the Docker host, which represents the system where Docker is running, and the Docker host consists of the Docker daemon that we have just talked about. So the Docker daemon is the essential background process that manages Docker containers, and the daemon listens to Docker API requests and processes them. And the containers, as we have said, these are the lightweight standalone executable software packages that include everything needed to run a piece of software, such as the code, runtime, system tools, system libraries. Now, Docker images are read-only templates used to create the Docker containers, and images, as we have said, define an application's environment, libraries, and dependencies. And Docker images from the registry can be pulled to the Docker host, and images on the Docker host can be pushed to the registry. Now, imagine you're developing a web application, and this application has three components: a web front end, a REST API, and a database. Now, in a traditional deployment, you'd need to manage the dependencies, libraries, and configurations for each component separately on your infrastructure, which could lead to inconsistencies or conflicts. But with containers, each component can be encapsulated with its specific dependencies into separate containers. So the web front end might be in a container that includes the application code and an Nginx server, and the REST API could be in another container with the application code and Node.js runtime. And the database, say for example PostgreSQL, would be in its container with the necessary database files and configurations. Now, when deploying, these containers can be orchestrated using tools like Kubernetes to ensure they communicate with each other, scale as necessary, and maintain high availability. And this approach also ensures isolation, meaning that dependencies for the web front end don't conflict with the REST API. And with this approach, we also ensure we've got high scalability, which means that each component can be scaled independently based on the load.